Stop guessing. Here's how to install Debian Trixie and LinuxCNC correctly. Are you tired of confusing guides and forum posts that lead you down a rabbit hole? Have you tried to get Linux up and running on a modern machine only to end up with a failed install? Do you just want someone to show you a straightforward, no-nonsense way to get it working on the latest version of Debian? If that sounds familiar, you've come to the right place. This isn't just another tutorial, this is my bulletproof method. In this video, I'm going to walk you through every single step to correctly install and configure Debian 13 Trixie and the latest LinuxCNC so you can get it right the first time. We'll cover everything from grabbing the right files and picking the best desktop for performance. And this is the most important part, verifying your system is stable enough to run your machine with absolute precision. So let's stop guessing and get this done. Section 1, the foundation, getting the right tools. First up, let's get our tools lined up. This is a critical step because starting with the wrong files is the #1 reason why installations fail before they even get started. We need two things, the Debian Trixie installation image and a tool to write it to a USB drive. Head over to the official Debian website and you'll see a bunch of options. Let's go there now. So just type into your browser, and I'm already there, debian.org. If I could see. And click on this link here. Click on this link here and download the ISO. You'll see now that we're downloading something. While we're doing that, we're going to need Balena Etcher. Now we can do that here. I just usually Google Balena Etcher. And it'll take you straight here. So download Etcher. And I'm actually doing this on a Linux machine, but you can see that everything is here. 64-bit Linux is the one that I need. Windows, Macintosh, they're all there. So I'll download this one, 64-bit is for me. You should be okay, but normally make sure that you get the AMD 64 version of Debian. And if you want to use that, it'll work for almost any modern 64-bit PC. The net installer is the one that's great because it's small and downloads the latest packages during the installation, which means our system is 100% up to date from the get-go. So while this is downloading, we'll get that Balena Etcher. Etcher is free, it works on Windows, Mac OS and Linux, and is incredibly reliable. The killer feature is that it verifies the write, which means it double checks that the data was copied to your USB stick without any errors. This one simple check can save you a massive headache down the line, so go ahead and download and install it. You'll also need a USB drive. Anything from 4 gig or larger will do the trick. So with Debian ISO downloaded and Balena Etcher installed, it's time to create our bootable drive. We're going to flash from a file. We need to pick up your downloads, pick up the net installer, open that, select a target, select a target, 15 gigabyte, I always like to look at the size. Select that. And all you have to do then is hit flash. This might take a few minutes, but once it gives you the green light, we're ready to install the operating system. Section 2, the main event, installing Debian Trixie. This is where we build a new home for LinuxCNC. I just want to give you a quick but important warning. This process will erase the computer's hard drive. So make sure you're installing this on a dedicated machine for your CNC and you've backed up any data you can't live without. So plug in the USB drive and we'll power it on. And sometimes you'll need to tell the computer to boot from the USB drive, and this usually means pressing a key on boot up like F2, F12 or so on, and right after you turn it on, and you get into the BIOS or boot menu. But in my case here on this PC, it just wouldn't let me do that. So let's just have a look at what this may look like once you've booted from the CD. You're greeted by the Debian installer, and we're going to use the graphical install. Got too many keyboards here. The first steps are easy. Just pick your language and move along. We want to pick, I'm picking English. And we probably will install on the right. I'm in Australia. Continue. I usually select American English, even though that there is an Australian option. We detect and mount the installation media now. So give it a couple of minutes. It's important to understand that when you do this, you should also always be attached to the network, even if you're not going to be attached to the network, and use a wired network. And you can see here that I'm plugged into that. And the next step, it asks for a host name. I'm going to default to Debian because it's easy to remember. And I'll continue that. Domain name, we don't have one. And the root password, we're going to leave this blank. I'm serious. Leave the root password blank. Just leave it empty and just continue. The installer will give you a little warning, but trust me, this is what you want. By leaving it blank, the system automatically gives your main user account sudo privileges, which is the modern and correct way to handle admin tasks in Linux. After that, go ahead and create your main user. So let's move on. Full name for the new user, I'm going to call it Debian because I don't want to get confused. If I type with the right keyboard, the username for the computer, I'll leave it the same. Here's a new password. It's your choice here. People would normally recommend that you use a secure password, but I find that I'm installing this all the time, so I'm going to cheat and I'm going to call this Debian. So when I log on, I've got a computer called Debian, I've got a user called Debian, and the password's called Debian. So that way I know exactly what I've got to type if I've got several computers floating around. So I need to select that I'm in Queensland. Which configures the clock. So now we're going to partition the disk. For pretty much everyone, the guided use entire disk option is the way to go. And in modern systems, we also get UEFI message here. So if you wish to install in UEFI mode and don't care about keeping the ability to boot one of the existing systems, you have an option to force that here. But we'd rather not do that. This is the secure boot side of things, and it can get very confusing if you enable it. Guided. So pretty much everyone's going to use guided, use the entire disk option. It's the simplest and best choice. It handles all these options for you. And we're not going to install in the SD drive that we're booting from, the USB stick. We're going to use the main one. And we'll see how we go. All files in one partition is really the way that we go here. Finish for a moment and we'll make changes to disk. So I'll just get me out of the road for a moment and we'll continue. Write the changes to disk. Yes, we want to do that. Once again, continue. So just confirm those changes and let the installer do its thing. The base system will now install. After a few minutes, you'll get to the most important choice in the entire process, the software desktop selection. You'll see a list of desktop environments, and your choice here has a huge impact on your system's real-time performance and latency, and also some systems just don't play with LinuxCNC at all. So here's a rule of thumb. If you're on an older PC with a low power machine with less than 8 gig of RAM, you absolutely must choose a lightweight desktop that supports Xorg, like XFCE, LXQT or LXDE, and also Cinnamon. These use minimal resources, leaving more horsepower for LinuxCNC. For the purists, if you want to stick with what LinuxCNC themselves use, they use XFCE, but some of the other systems are a bit more easy to use, and I happen to like Cinnamon. For modern PCs with 8 gig of RAM or more, you can get away with Cinnamon or Mate. So whilst GNOME is on the list, it's known to be a resource hog and is based on Wayland, which is not desirable for LinuxCNC. So I'd steer clear. So let's just wait till we get there. You can see Trixie here on this install disk is using 6.12, kernel 6.12. So it's a very modern one, and that's the one that will have Linux, not LinuxCNC, Linux long-term support. Mirrors are something that we use to save some bandwidth when you're installing things. So I'm in Australia, so I'm going to select Australia, but sometimes you don't need to bother about this so much today because let's face it, the internet is pretty good. So I'm going to continue with Australia, and I'll just pick Debian.org as our base, but there are these other mirrors. And if, say, you were on an ARNet network, you might choose to use it. Proxy information. I don't use a proxy in my network. Most people will leave this blank. APT is important. It's the package manager. This is how things get installed in Linux and with Debian. So APT is the program you use. So we'll just wait yet a little bit longer. The installation is a two-step process. First, everything is downloaded, and by using the net install, you're guaranteed to get everything current as of today. So we're installing this, and it's downloaded all the programs, and now it's actually configuring them. There's a bit of a game here for people that are Debian developers, but we always just say no here. So here's where we're going to select that. I'm just going to select Cinnamon, you might like to select XFCE. You won't, I would normally turn these off because we don't want to get confused, and standard system utilities. So we should just be able to select those now. XFC, I'll just make it XFCE. As you can see, this is the longest part of the process, so now is a great time to grab a coffee, and I'll probably speed this up or delete it for the video. Once it's done, the installer will tell us to remove the USB drive and reboot. This computer we're installing on is a very old, 15-plus-year-old HP desktop machine, and they generally make good candidates. This one in its day was a 4-core i7, and it has been running Windows all that time, but it just got to the stage it's unusable. Normally when I install one of these, I will start with a brand new SSD, because they're only $30 or $50 these days, and I find that then makes them a lot faster. But in this case, I'm just going to use reuse the original hard drive. So it looks like we're nearly getting to the end of it. So yes, we're going to say yes to this. We previously said that we were going to install Linux into the whole drive. So saying yes here is quite safe. So we're going to install Grub onto the hard drive, not onto the verbatim USB stick. Okay, finally, the installation is complete, so it's time to boot into your new system. Remove the installation meter and press continue to reboot. I'll see you on the other side. Congratulations, you've just got a fresh, clean installation of Debian Trixie. So we'll just pause for a moment. The heavy lift on the OS install is done now. If you're finding this guide useful and helpful and easy to follow, do me a quick favor and hit that like button. And if you want more no-nonsense tutorials for your CNC and workshop projects, make sure that you subscribe so you don't miss what's next. Your support really helps me make more videos like this one. So now let's get back to it. We can log in using your user credentials. You can see at the top of the screen that we've got the name of the computer here, so I know what my username is. If I type in the right keyboard, and password, so there we go. A nice, easy to find XFCE desktop. And our menu is up here, and there's a few things that we want to do just to tidy this up. First thing, so what we want to do is open up a command prompt, and all we're going to do is type in sudo to work as the administrator. I'm just going to move my old keyboard out of the way. Sudo apt update and enter our password because we've got to log in as administrator. And this just updates the system. So the secret of all this is the real-time kernel. So we're now looking at our new desktop, and we've opened up the terminal, and we'll do a little bit more magic to tidy this up. If you wanted to, at this point, you could do a sudo apt upgrade. And there's nothing to upgrade because we're fully up to date. So now let's get on with LinuxCNC. All we have to do to install that is go sudo apt install LinuxCNC uspace. And also we type in LinuxCNC uspace dev. And that picks up a few other handy utilities that are more for developers, but I find that I end up using them all the time. And if you're a Mesa card user, you would also type in Mesa Flash at this point. I won't do that. I don't need that. So we're going to continue with this. We could have put a -y here and it wouldn't ask the question. So what's happening now is that the LinuxCNC deb file defines all the dependency programs that are required to run LinuxCNC. So what's happening now is we've gone out into the system and we're installing all of these files as part of it. And you can see that we're 60-odd% of the way through it. And you can see here at this point, which is the exciting thing, is that we're installing the real-time kernel, which is automatically done for us when we install LinuxCNC. We've already started, but we get to installing and configuring LinuxCNC. So we're finally installing it, and as of Debian Trixie, a recent version of LinuxCNC is included right in the official repositories, which has made our life a lot easier because we just install it from the packages as we're doing now. As we said, the most critical piece of puzzle for a standard LinuxCNC setup is the real-time kernel, and we saw that that was being installed. So the current kernel that we're running is designed for general use, which is about getting a lot done. And in the ordinary kernel, getting a lot done is more important than when it gets done. For CNC, we need a kernel that responds. That's exactly what the preempt RT or real-time kernel gives us. It's not about making your computer faster. It's about making your computer more precise. And that's what we need for LinuxCNC. Once the packages are installed, LinuxCNC is ready to go. But we would need to first reboot the computer to load up that real-time kernel. So we're nearly there. Perfect. So now it's time to reboot the computer so that we pick up the real-time kernel. So let's just do that. You can do it from the command line here, sudo reboot now, because we don't want to wait about. We log in again with our highly secure password. And we'll open the console one more time. And we want to type in uname minus A. And you can see now that we have a preempt RT kernel, and it shows here that it was Debian 13 real time. So that part of it's successful. And now in the menus, we should have a CNC menu, and everything we need about LinuxCNC should be here. So we can just run LinuxCNC from the command line, and you get this chooser. And probably, I'm in a metric country, probably the most important one to use is the axis, which is the original desktop. And would you like to copy this into the desktop so you can customize it? We'll say yes to that. So it did that. And now it's open. So there you have it. There's LinuxCNC. And I do prefer, and it's recommended, particularly when you're configuring a system, to always start LinuxCNC from the command line, because when this happens, if something goes wrong, you'll get a lot more error messages and useful debugging information in the window here. So if I close that again, and I'll try and pick something else. And there's a lot of sample configurations here. And for milling machine, I quite like there's the Qt plasma in imperial metric, and there's also a portrait. But Qt Dragon is the one that I quite liked for the standard axis milling machine, and once again on metric. I'll install that. So this screen is not big enough for it, so I'm not quite sure how I'm gonna. So this is an older machine. It requires a 180p desktop. So I'm just going to somehow get out of that, but the exit buttons are, maybe I can close it. Yes. That's better. So we've proved that we're golden. And the other thing that we can do is run a latency test, which is in the main menu here, which shows latency of it shows the latency of the machine. So the servo thread seems to be really, really fast on this machine. And the base thread is also quite good. So because this is before all the was built before all the power saving features were built into the desktop. So we'll just close that. But the one that I like to run is latency histogram. and I put /-sbins 1000. Now, this is the number. This is the same data, but it's presented in a more interesting and usable format. So here is the base thread, which would be used for a parallel port machine, and here is the serial port. This is the servo thread that everything is run off. But normally, if you're running, I put in also -- no base. If you're running a machine like with a MESA card, or you're using EtherCAT, you don't need a base thread, so it just confuses it and makes things go a bit slower. So most of the time I just run it as this, so that's that. And finally, I want to install a couple of useful tools. So I'm going to put sudo apt install Geany, which is the text editor I like to use, and gedit, which is one that's in the LinuxCNC default, so we'd better install that as well if it hasn't been already, and grub customizer. And my password. Yes, I forgot to type -y. Always do that. So you'll find Geany is now in the, I think it goes into development, because it's very useful. If you've used Notepad++ at all on Windows, you'll be familiar with the Geany environment. But it's just as easy to type it here. And there's our text editor. So, and I'll just go back to, an up arrow will take us back. I just want to go back here and see it's got no isol CPUs. The other thing I want to do is edit, create Autologin for you. So if we go sudo Geany, because I like Geany, a system file called etc. lightdm, which is the environment that XFCE uses, and we want to edit its conf file, lightdm.conf. And round about line 127, it used to be, is logon, auto logon here. So auto logon, I'm going to make this, I'll enable that, and auto logon user equals Debian, and timeout straight away. Now, the next time we log on, you won't need to type your password, username and password. So it's up to you to decide whether you need to do that. So I can close Geany now. And let's just go on and just see there's a couple of things. The moment of truth, latency testing. How do we actually know if your computer is up to the task? Well, we test its latency, which we've already done, but we'll just do that again. And we can see now that high jitter, which is what this is displaying here, is what relates to sloppy timing, which can lead to bad surface finishes, inaccurate cuts, and just failure of LinuxCNC. So this is the test environment that I prefer. There are other ways to do this. And the other thing up here, it says it's got 8 cores. This computer has 8 cores, so it's not that old. It mightn't have had any HDMI ports as an output, but it's certainly got 8 cores. So I think what we should do is, for completeness, we'll just do one more thing. And we can go sudo grub customizer. This is correctly installing or loading the real-time terminal. We've already tested that. And under general entries, you can say which one of these entries. Sometimes you'll have multiple options, and it says to use the first option here. So that works well for us. And the other one, we can type in isolcpus equals, these start numbering at 8. We might just try start numbering at 0. So we might type 6,7 here. And what this will do is on a reboot, it will tell LinuxCNC which cores it can use, but really only needs 1. So maybe I'll just put 7. Put 2. And that's done. And we can save that and quit. Sudo reboot now. So we'll talk about this max jitter on the latency test, which is the worst case timing hiccup that has been seen. And it's measured in nanoseconds. So for good performance with software step generation, like for a parallel port, this number on the base thread needs to be below about 20,000 nanoseconds or 20 microseconds. If you're using a MESA card, the system can tolerate a lot more, but lower is always better. If you can see this number spiking much over 100,000 nanoseconds, this computer probably isn't a great choice for running a CNC. So you might have to dig into the BIOS settings like power management to disable some features there. So what we should do is run things and stress the system. So if we go back to the terminal editor and see if it kept that there for us. Now it shows that I've got isolcpus 6 and 7 on this reboot. And I don't know whether that's changed that much, but if we open the web browser, here we go. I opened it twice. And if we go to YouTube, if that works, here we go. This is the earlier video that we did. So if we just run this for a little while and bring that to the foreground. And what we want to do is of course we get ads. But what we want to do is abuse the computer and make sure that it's going to work okay. So while we're running this latency test at the same time. So, and the other thing is to make sure that you can move windows around, because sometimes on a marginal computer, you might do that in practice while running a machine, and you don't want this to go out the window when you do that. So, and the other thing that's here is this thing called GLX gears, and you can add a few of those, and this actually just adds some more load to the computer, and you probably don't need more than about 8. And you can see that this hasn't moved, so this is a really good, well set up system. So that's the end of our story. So we've installed a stable, predictable system that has the confidence to let you know that it will run a machine. And there you have it. A complete, correct installation of Debian Trixie with a real-time kernel and LinuxCNC, all topped off with a successful latency test. We've gone from a totally blank hard drive to a fully configured and performance-verified CNC control system. The key takeaways are simple. Use a lightweight desktop like we did, XFCE, for the best performance. Always, and I mean always, install and boot into the real-time kernel. This is not optional. And finally, always run the latency test or latency histogram to validate your setup before you even think about connecting it to your machine. Now you have a rock-solid open source foundation from all your CNC projects, and from here you can dive into creating your machine configuration with tools like PNC-Conf for MESA cards, or by getting your hands dirty editing HAL and INI files. The guessing is over. The time to start making stuff. Thanks for following along. If this video has helped you conquer the installation, give it a thumbs up. And don't forget to subscribe for more tutorials on CNC, machining and making things work. Check out my other videos for more detailed Linux CNC setups. So now go and have some fun with your new rig.